So these notes are for integrated one. This is on something called area models. So we're going to write the title area models. And this is going to be dealing with the algebra tiles that we were doing the other day. But instead of drawing them all out separately, we're going to use what we call a generic rectangle or area models. So just as a little reminder, we had some algebra tiles that we're dealing with the other day. Okay. And we had ones that were big squares that were x by x, and we multiplied them, we got an x squared. And then we had ones that had the same length, but the width was only a 1. So it was x by 1, and the area of these was x. And then we had some little squares that had a width and length of 1, and 1 times 1 is 1. And we were using these to build rectangles. So for example, what we did yesterday was we were asked to maybe do the following: to make a rectangle with 1 x squared, 5 x's, and 6 1's. Okay. And we were asked to then to write the area as a product equal area as a sum. Okay. So if I was doing this, what I'm going to do is I am going to have my x squared, okay, that I'm going to start with. And then my x's, I need 5 of them. Now, as I'm doing this, you might think, okay, let's just kind of keep lining them up. Okay, so right now I've got 5 of them. The problem is I also have these little ones, okay? And these little ones would go like that. And every time I have one of them, I need something else to go underneath that x squared. So what I'm going to do is I'm going to kind of adjust these. And let me take one of those away and instead put it underneath here. Okay. So right now I have 1, 2, 3, 4, 5 of these. And now let me get my 1. So I've got 4 of these I'm going to have here. I need 6 of them. So the problem is that when I'm doing this, I need to have 6, and I'm going to have 2 of these left. So I need to split my 5 in a way to get 6 items. Okay. So I'm going to split the 5, not as a 1 and a 4, but as a 2 and a 3. So let me get another rectangle and let me add another rectangle here. So now I have 5 of these. And now what can happen is I can move this down here and I can end up now having 6 of these. Okay. So I have my x squared. I have 1, 2, 3 x's, 4, 5 x's, and then I've got 1, 2, 3, 4, 5, 6. Okay. So you see right now that when I'm trying to find area as a product equal area as a sum, my product is the inside, which is going to be the x squared plus I've got 5 x's plus 6. My outside area, when I'm doing this, this is going to be an x, this is going to be an x. And then when I'm looking at the top here, this is a 1, a 1, a 1. Okay, so I really got an x plus 1 plus 1 plus 1, which really is an x plus 3. And then I have an x plus 1 plus 1, which really is an x plus 2. So this is going to be an x plus 3 times an x plus 2. That's my areas of product equal areas of sum. Now, it's a pain to have to draw these out all the time, okay? So is there another way we can do them? Well, the way I have it grouped, and I was kind of talking about this the other day, it's nice to group them in a certain way. Here's all of my x squareds right here. And then I have my x's grouped here and here, okay? So in 2 sections. And then I have a 4th section, which is just my ones. That's what we're going to do with our area model. But instead of drawing out each of these rectangles individually, what I'm going to do is I am going to, I am going to draw an area model. Okay, so I'm just going to draw a rectangle. I'm going to split it into 4 sections here. Why 4 sections? Because I have what we call a binomial, x plus 3, which are 2 terms, times another binomial, another 2 terms, x plus 2. So I'm going to have basically a 2 by 2 area model. I'm going to have my x here, my plus 3 here, my x here, my plus 2 here, and then I multiply to get the insides. So when I'm doing it, this x times x is going to give me this box, which is an x squared. This x times 3 is going to multiply and get this box, which is going to be a 3x. This box is going to be a 2 times x, which is a 2x. And then I'm going to have a 2 times 3, which is a 6. And so you see my area as a product is my outside, my x plus 3 times my x plus 2, okay, just like it is here. And then my area as a sum, here's my x squared, just like this. Here's my 3 x's. Instead of drawing them out separately, here they are. This right here is my 3x. And then here's my 2 x's, but instead of drawing them separately, I'm drawing it in one box and saying that that's my 2x. And then instead of drawing out 6 individual ones, my 6 is right here. So that's what we're going to be doing. So let me give us an example here. So let's say, for example, I have x, let me put a number in front. How about that? Let's do 2x plus 3 times 3x minus 4, okay? Now, when I'm deciding to do this with an area model, okay, and really what we're doing is we're really multiplying this out. That's what we're doing. I've got 1, 2 terms here, 1, 2 terms here. So I'm going to draw a 2 by 2 box, okay? So I'm going to draw a 2 by 2 box. And I'm going to write 2x and plus 3 and 3x and then minus 4. I like to put my negative with the number so I see it. And then I'm going to multiply. So this box here is a 2x times a 3x, which is a 6x squared, okay? And x times an x is an x squared. This box here is a 3x times a 3, which is going to be a 9x. This box here is a negative 4 times a 2x, which is a negative 8x. And then this box here is a negative 4 times 3, which is a negative 12. So then when I'm going to do area as product equal area as sum, the area as a product is the outside. So that's going to be the 2x plus 3 and the 3x minus 4. Kind of, it's the original problem. So 2x plus 3 times 3x minus 4 equals, and my area as a sum is going to be the inside. And this is actually my solution. This is my product. This is what I get when I multiply out the binomial 2x plus 3 times the binomial 3x minus 4. And so I get 6x squared plus x minus 12, and that's my answer. Now, let's say I have something like this. Let's say I have 3x plus 2 times 5x squared plus 2x minus 7, something like this. Now, what's going to happen in this case, I have two terms, 3x and 2, and over here I have three terms. So I'm going to have either a 2 by 3 or 3 by 2, depending on how I want to draw it. So for this, I'm going to have a 2 by 3 box. My 2 is going to be the 3x plus 2. The 3 across the top is my 5x squared plus my 2x minus 7. And then I'm multiplying to get each of these boxes. Now, when I take a 3x times a 5x squared, that's going to be a 15x to the third. This box here is going to be 2x times 3x, which is 6x squared. This box is a negative 7 times a 3x, which is a negative 21x. 5x squared times 2 is a 10x squared. 2 times a 2x is going to be a 4x. And the last box is going to be 2 times negative 7, which is a negative 14. So what's basically happening is this whole first row is going to be 3x times the 5x squared, 3x times the 2x, and then 3x times the negative 7. That's how I got each of these. Then the second row, I'm taking 2 times 5x squared, and 2 times 2x, and 2 times a negative 7. And then my answer, I'm going to have a 3x plus 2 times a 5x squared plus 2x minus 7. That's my areas of product. And then my areas of sum is going to be all of the like things here. So I have, let me just kind of highlight the ones that are like. So this is my only x cubed. These are both x squareds. These are both x's. And then I have my number. So I'm going to get a 15x squared, 15x cubed plus 16x squared minus 17x minus 14. And that's going to be your answer. I'm going to do one more example. And this example, let's say I have a 2x times 3x plus 5. Now, in this case, this is a monomial, it's one term, and this is a binomial, it's two terms. So I'm going to have a 1 by 2 box, okay? 1 by 2. So I'm going to have 2x, and then I have my 3x plus 5, and then I'm multiplying. 2x times 3x is 6x squared. Remember, x times x is x squared. 2x times 5 is a 10x. And so then my answer is going to be 2x times 3x plus 5 is equal to 6x squared plus 10x, and that's your answer. And so you guys are going to be coming up with these area models, okay? You guys are going to draw them. You're going to count how many terms. So this is one term and this is two terms. So I did 1 by 2. This one here has 2 terms and then 3 terms. So that's why I did 2 by 3. This one here has 2 terms and 2 terms. That's why I did 2 by 2. And that's what you're going to be doing on your homework. And again, this is to be copied into your composition book.